All right, my friends, it's another fun episode of video lessons. Um, I asked Mr. Liberty to make copies of this, so hopefully that happened. If not, I suppose you can take notes on Notability, or you can just watch and learn and be brilliant that way. And then the worksheet is the same worksheet from Monday where we only did the ones that were in degrees. Now you're going to have the ability to do the ones that are radians. You know everything. It's going to be awesome. We are still having our quiz on Friday because A, I really, really hope I'm back tomorrow, and B, we just got to stay on track. We don't have additional time. So, I don't have the ability to pick people for academic seminar, or I should say I don't know who wrote their name on the paper copy. So if you want to be an academic seminar, fill out the link that's on Schoology, and that way I'll know that you need to come in for something. I'm going to choose people today, but I don't know who to choose. All right, so we're going back to the unit circle. We took a day to do conversion, and so now we're going back to do the unit circle, but in radians, because honestly, you need to know radians more than degrees because that's what they use in calc. So the angles aren't going to change. It's just like the temperature. The temperature is not different when it's a Celsius versus Fahrenheit. It's just the way you label it is different. And then the coordinates don't change either. So we're going to practice filling that in. One of the things you'll have to do on the quiz is fill in one coordinate. So you'll be assigned coordinate 1, 2, 3, 4, and you'll need to fill in the coordinates and everything in that one quadrant based on the patterns that we learned. So we'll practice that here. The only way to know how to do that is to run yourself through it a few times. So in the blank notes, there's a blank unit circle. You can plop it into Notability, practice, erase, whatever you want to do. Okay, so let's think about the main angles that we use. And the key feature is that pi has a value of 180 degrees. They are interchangeable. So you're going to have to just kind of use your big brain as you go through to make this less stressful. If you try to memorize it, it won't work. So you have to use a little bit of math and a little bit of common sense. So if you think about degrees and radians, 0 degrees is 0 radians. They are the same. Because keep in mind that our conversion that we learned was to take degrees and then you're going to multiply it by pi over 180 so that the degree unit can cancel and you're left with a fraction of pi. So if I did that here, if I took 30 degrees multiplied by pi over 180, and then I would have to go ahead and reduce the 30 over 180, and I'd end up with 1/6 pi. So we call that pi over 6. Now think about it. If you want to look at it this way, this is true. Pi is the same as 180. So is it true that 180, because I can replace pi with its equivalent, over 6 would be 30? Yeah. So pi over 6 is going to be a super popular one because there's so many places that are 30 degrees apart on our unit circle. Same thinking. 45 degrees. If I go to do my conversion, I'm going to end up thinking, what fraction of 180 is 45? And the answer is pi fourths. And again, that means if you think 180 is the same as pi, when I divide it by 4, do I get 45? Yes. So keep in mind, that was all of our middles. All the points in the middle were multiples of 45. So all the points in the middle of our quadrants should be some form of pi over 4. And then 60, I don't even really know that I need to do a ton with 60 because 60 is just a multiple of 30. But to make myself feel happy, I'll go ahead and do 60. And when I do, these reduce to be a third. So pi thirds. So in my same fun little approach that I'm obsessing about over here, I would say, okay, that's the same as having 180 over 3, which is going to land me at 60 degrees. Perfect. And then 90 degrees is going to be at the top of the circle, and then the corners, the top, right, left, bottom are all 90 degrees apart. So when I look at this, that reduces to a half. So I have pi over 2, and just because I want to do everything samesies, I think, is it true then that 180, which is pi, over 2 will get me to 90? And the answer is yes. So these are going to be the fractions that we see repeated on the unit circle. And if you watched the video yesterday all the way through, it got kind of long, but I did sort of foreshadowing, go through the unit circle and filling that in. And I gave you the same hint yesterday as I'm going to officially put on the notes down here. The easy way to fill in the angles on the unit circle in radians is to go around. You can do these in any order, it doesn't matter. Say that you remind yourself that the middles are odd quarters. And by that I mean pi over fourths. Meaning, when I look at my unit circle, all these middle marks, which are 45s, remember it takes 45 degrees to get into the middle of a quadrant, those are going to be marked as fractions of pi over 4. Now, the reason it's only the odd ones is if from here I went 45 more, I'd be at the top. And that would be 2 pi over 4, which would reduce to pi halves. And so the next one that I actually have to write in fourths is over here at 3 pi fourths. And then if I continued to here, that would be 4 pi fourths, but that would reduce to pi. This bottom left in quadrant 3 is 5 pi fourths. The bottom would be 6, let's think over here, 6 pi fourths, because I'm counting by pi fourths, but would reduce to 3 pi halves. So it doesn't look like a pi fourths. And then here I'm at 7 pi fourths. All the way around would be 8 pi fourths, which not surprisingly reduces to 2 pi, because that's what all the way around is. So if I start with that by marking my middles, I'm going to see that my middles are odd pi fourths. 1 pi fourth, 3 pi fourths, 5, and 7. Everything else is going to be a multiple of 30. And by being a multiple of 30, I just learned that it's going to be a multiple of pi over 6. So then I'm going to count by pi over 6s to fill it in. And just like I was doing a minute ago, I need to reduce my fractions because we're in pre-calc. So I'm going to start here, and my first 30-degree mark is right here. And I'm going to fill this in with my first pi over 3. So 1 pi thirds. Jumping 30 degrees, I'd be here. That would be at 2 pi thirds. Oh, wait. I had like a brain fart, sorry. I said to count by pi over 6s and then I didn't. So let's do what I actually said. This is going to be pi over 6, sorry. This would be 2 pi over 6, but that reduces, so we actually label it as pi thirds. Then at the top, I'd be at 3 pi over 6, which would reduce to pi halves, but we already labeled that. Then I would be at 4 pi over 6, but that reduces to 2 pi thirds. After 4 would obviously come 5 pi over 6. That doesn't reduce. Here I'd be at 6 pi over 6, but that would land me at pi, which I already filled in when I reduce it. Then 7 pi over 6, which doesn't reduce, so that's here. 8 pi over 6 reduces to 4 pi thirds. At the bottom, 9 pi over 6 would reduce to the 3 pi halves that I already have. Then my next mark would be 10 pi over 6, but that reduces. And then after 10 would be 11 pi over 6. And if you went all the way around, you'd be at 12 pi over 6, which would again reduce to 2 pi because you're all the way around. So I need to be able to do two things. I need to be able to find angles in degrees or radians, because that's my where. That's telling me where do you go. And then my what is going to be the coordinate that I'm supposed to find when I get there. And the coordinates, remember, we have our x and y like we've always used. We're now thinking of as cosine and sine. And then we might have to flip those over if life gets hard. Okay, so the other day we talked about short, medium, and long. So all the short pieces on here are 1 over 2. All the mediums are root 2 over 2, either plus or minus, keeping in mind that those are reserved for the middles. And then anything that's a long leg is going to be root 3 over 2. So let's pretend I got quadrant 3 on my quiz to fill in on Friday. I don't have to fill in the whole entire circle, but I would have to go, okay, to get here, I'm going back 1 and not up or down at all. There's not a triangle there. But what if I go to here? I'm going to go back long, down short. So the coordinates there are negative root 3 over 2, because that's a back long. And then down short is going to be a negative half. Next time in the middle, middles are always root 2 over 2s. So I would have gone back root 2 over 2, down root 2 over 2. All the middle marks around the entire unit circle are simply root 2 over 2s. And then you just decide the plus minus based on what quadrant you're in. And then if I had this quadrant, I'd go back a little, just a short guy, and then down. So this would have the coordinates negative 1/2, negative root 3 over 2. And then straight down would put me at 0, because I didn't go left to right, negative 1. Now, for the rest of the quiz, after you filled that in and turned it in, you'll have a filled in unit circle so that you can go through and answer the kinds of questions that are here. So what I like to do is think about it. Like this is sine, so that's the y coordinate. This is cosecant of the same thing. So I'm just going to have to flip over my sine. So whatever that answer is, I'll flip it over. Cosine is x. This is secant, so that is going to flip over x. And again, it's the same thing. It's negative pi 6th. So I'll just be flipping that x over. And then these last two are going to be tricky to find, so we'll have to kind of pay attention to that and how we go about that. But when I get where I'm going, I'll find the y. Here, when I get where I'm going, I'll find the x. Okay, so let's do this first one. 2 pi thirds, that's my where, and that is right here. And then I'm supposed to find the y. Well, I don't have that one filled in, but it's back a short, up a long. So that would be negative 1/2 up root 3 over 2. It's asking for the sine, which is the y value. So if I go to that 2/3 pi and I find the y value, my answer is going to be root 3 over 2. Excuse me. And then here, I just flip it over. Cosecant, we learned from the very beginning, just takes your y or your sine value and flips it over. But then we have to rationalize it. So we end up with 2 root 3 over 3 as that cosecant for 2 pi thirds. Okay, this one is negative. So think about what that means. If I go positive pi over 6, I'm going to be going up this far to the first mark. Well, negative just means go the same distance the other direction. So I would go to here. This 11 pi over 6 is the same as negative 1 pi over 6. It's just called a different thing. Because instead of going all the way around to get there, I just scooted down. Okay, so it's asking for the x coordinate there. Well, let's figure out what the coordinates would be. To get to that, I went over long, down short. So root 3 over 2 and down a half. Well, these are great examples because this ends up being the same thing, which happens all the time because there's only 3 units that you're using on the whole thing. The beauty of that is when it asks for the secant here, I just have to flip that answer over, but the answer up here was the exact same thing. So I already know I'm going to get 2 root 3 over 3. You're going to have a ton of repetition because you only have these three things to work with and then a couple zeros and ones. Okay, these are going to be thinkers, and I want to make sure that we talk about this because you'll see them on your quiz. How do I find this? What I always encourage people to do is think about the two main spots. Over here is 1 pi, and over here all the way around is 2 pi. If, like in this problem, you were dealing in thirds, meaning there's a 3 on the bottom, you would have had 3 pi thirds at this spot. And then all the way around to get a 2 pi, you would have had to have 6 pi thirds, because 6 over 3 reduces to 2. So the reason that's helpful to me is now I can go, okay, I'm starting at 14 pi over 3. One time around the circle is going to take away 6 of those. But now I'm at 8 pi thirds. So I can go around again a second time, and then I've used up 6 pi thirds again, because that's every trip around the circle is 6 pi thirds, which is equivalent to 2 pi. So when I do it again, now I'm at 2 pi thirds. Excuse me. So this is going to land at 2 pi thirds. It just means that you started here, you went around once, which was equivalent to 6 pi thirds. A second time was up to 12 pi thirds, because 6 plus 6. So I had to go 2 pi thirds more. It doesn't matter how many times you go around to get there. It only matters where you land. We were already here, so we already have our coordinates, and this one is asking for the sign. So it is actually the same question as the one up above, because it's asking about the same spot. It's just weird to get there because we had to go around the circle more than once. And that can be tricky. And so same thing's going to happen here. 11 pi over half, or excuse me, 11 pi over 2. This is always 1 pi, and this is always 2 pi. So if you're counting by halves, this would have to be 2 over 2, so that it would reduce down to the pi that we know it's supposed to be. And this side would have to be 4 over 2, so it would reduce down to 2 pi. So here I would go around once. That would be 4 pi. Oops. And then I would go around, go away. I'd go around once for 4 pi. Then a second time, I'm struggling. Let's try that again. It keeps making my perfect circle, and I don't need it perfect. So if I go around once, that's 4 pi over 2. Second time would be 8 pi over 2. And so then here would be 9, 10, 11, because pi over 2s are our 90-degree marks. So down here is my 11 pi over 2. If you want to start out and do it subtraction like I did the last one, you'd say all the way around is 4 pi halves. Now I'm at 7. All the way around again is 4 pi halves. Now I'm at 3, which is on my unit circle. So I'm at the bottom, and it's asking for the x. So my coordinates are 0, -1, and my x is 0. So in essence, it's nothing complicated. You got to figure out where to go and then what to report once you get there. But in reality, since you could be in degrees and it could be radians and you could be going around more than once, everything's easier in degrees. If they say 400 degrees, this concept I was showing you is easier because you can easily go, oh, that's 360 all the way around. So that's going to make me go 40 more degrees. That's easier because we're used to it. Dealing with radians is trickier because it's fractions and not as familiar to us. But just break it down, walk yourself through it. Where am I landing and what coordinate am I reporting once I get there? So like I said, go back to the original worksheet from Monday. So what does that look like? This guy. Now we aren't going to stop anymore because now we know how to do all this. This is going to be conversion practice. So you got to do these guys. And up here, we now have the ability to go through and say, okay, we can find these spots because we know or have our unit circle labeled in radians. And then we'll be able to do these and find up what quadrant they're in. So, okay, this one looks really awful, actually. So here we go. Think about this again. 18 on the bottom. This has to be 1 pi. This has to be 2 pi. So to be a 1 pi with an 18 on the bottom, you'd need an 18 on the top. This is asking me for what quadrant I'm in. It's not asking for anything specific. So if this is quadrant 1, 2, 3, 4, and I'm going negative 17 over 18. I'm going this way, but I'm stopping shy of this part because that is 18 over 18. So 17 would be somewhere in here. Therefore, it would be in 3, but I don't have to know anything more specific than that. So it's going to take a lot of brain cells rubbing together to do this stuff. This is conversion like from yesterday. So if you had trouble with the conversion, go back and look at your conversion notes. Take your time, become super duper smart. Tomorrow we'll practice together. Hopefully I can come to school tomorrow. And then on Friday you'll be so smart that your quiz will be easy peasy. Have a good day, you guys. Don't forget to sign up for academic seminar on the link if you need help tomorrow or you need time or you need to make something up because it is sort of crunch time for the semester.